This will be an update video on the climber for the 2016 robot. And I looked into some things, and my original mechanism for a winch is a possibility, but I think I've found a couple different solutions for how to do so. Andy Mark has recently come out with a winch that hooks up with their Rocket Box PTO gearbox, and that could work. It's expensive though. I don't want to if I don't have to. Plus, I'd like to get the experience of the design. So something that I thought of doing was for the lock mechanism to actually use a window motor to activate a hammer to go onto a ratcheting system so that it doesn't have to be spring loaded. It can be activated at the end of the match to lock the mechanism, and it would be a similar pulley to what I had before, where I have a sim motor with a sprocket hooked up by a chain to a hex shaft that's suspended a little bit just for pulley size, and the winch mechanism would go from there. That was one of my ideas. Another one would be to take a ratcheting wrench and fit it with a bit for the 1/2-inch hex, and just do that. Get it to be static. Get one of the ratchets that it's switchable, so that at the beginning of the match, switch it to it can't go the other way, and then reverse it to pull the cord out in between matches, lay it flat. There's that. And then for the actual scissor lift, it's quite a bit of height to go on. I checked out FRC Team 195's robot and talked to them for a little bit, and they ended up using torsion springs in order to activate their lift. Now, I don't know how they held it from lifting in the middle of the match and only activated at the end, but I have a few ideas. If we did get torsion springs on the, hold on, just getting my prototype. We did get torsion springs like between here and here, and then if the entire system was released, they pull together, which might do the trick and actually be able to avoid pneumatics. The other possibility for avoiding pneumatics, which is something that I'm trying to do here because we don't have a lot of experience with pneumatics, and I'd like to do a less serious project with it before we implement it onto our robot, especially with our space issues. Pneumatics take up a lot of space. Trying to fit everything even without pneumatics is very tricky. Would be to use an actuator. And I found a few, and we could try to make our own. They're not tremendously difficult. You can change up the gear ratio. It wouldn't be tremendously difficult. I'd prefer to just get a standardized one though, because it wouldn't hurt. An actuator is just a motor that turns a gear or a series of gears depending on the ratio wanted, and then the last gear spins a screw, and then there's a pull that's on that screw that's threaded, that when the screw spins, the pull will slide. And that could work as an alternative to pneumatics. However, that would mean that would take up a sim motor, which would mean we would only have the capability to use one more sim. So the winch could only use one sim, which wouldn't be horrible, but it's not ideal by any means. So just running through a few things I don't want to forget. I haven't done any drawings for this yet because I'm still running through a few possibilities. Once I figure out exactly what we might want to do, I'll start to go for that. I'm going to be trying to get a little bit of a team together because Annabelle, who's working with me on this, is going on vacation pretty much until our next competition. So it's she's not going to be able to help much with the project. So I'll try to pull a few people to help me. Otherwise, I'll be doing a lot of the designing. One thing I forgot about was the material for the scissor lift, what to use, because wood is a possibility. It's not something you commonly find on a lot of robots, but we have it, and it's light. The scissor lift does not have to be strong, but it has to not catch, which is a big part of scissor lift. So having something that's easy to make and easy to switch out could be highly useful, especially it's very lightweight. You can make it thinner, smaller, and I'll see where that goes. I don't think I'll be using the 1-inch Vex tubing that I was originally going to use, just because of how many stages we probably will end up having. I think that's all that I specifically want to talk about for this.